Hello students, Miss Slyman, now back with binomial distribution. So you're probably wondering why we learned the binomial theorem and what that has to do with probability. Well, it comes in with probability because it's a special type of discrete distribution. So in the case where you have an experiment that has only two outcomes, and normally those two outcomes are true or false, or we often say success or failure, then we call these Bernoulli trials, and it turns out that the probabilities of these can be found using the binomial distribution. So what we need is, first of all, there's a fixed number of trials. So we flip a coin 10 times or 50 times. In each of these trials, there's only two outcomes, success or failure. So in the case of flipping a coin, maybe heads would be success and tails would be failure. Each trial has to be identical and independent. The probability has to stay the same. So that goes back with being independent. So probability of success is P. Since there's only two outcomes, probability of failure is going to be 1 minus P. So in this case, we can find the probability of the distribution equaling a certain value. We can use our binomial theorem to find that probability. So we denote this as X is a binomial distribution with number of trials and probability of success. Sometimes you'll also see this. X is binomial with NP. So N and P are our given outcomes. Okay, so let's look at this one. So this one we're not told what the distribution is or what the exact example is, but we're told that it's a binomial, so our n, a binomial distribution, our n value is 5, so there's 5 trials we're doing. Probability of success is 60%. So find the probability that x is equal to 4. So probability that x equals 4, that's going to be n choose 4 times 0.6. Oh, and I shouldn't have done n because we know our n value is 5. So 0.6 to the 4th power, and then 0.4, so this is probability of failure, is going to be to the 1 power. Remember, these two are always going to total the n. Yeah. All right, so 5 choose 4. I think that is 5, because we're going to have 5 factorial over 4 factorial times 1 factorial. That's 5. I have no idea what that is, or, well, I do know what that is, it's 0.4. So put it in our calculator. We've got calculator 5 times 0.6, 0.6 raised to the 4th, and then times 0.4, 0.2592. All right, so that's how we use our binomial distribution. I'm going to come back again and show you with a word problem.